All right, next question. Okay, we're training a multi-classification model to predict movie genres. The specialist wants to evaluate model performance through a visual representation of different metrics. What will we use? Now, typically when I do this, by the way, I have in the past, especially like if you do the exam crams with me, I'll give you like 2.5 minutes to actually answer the question, just so you know. So if you hear these long pauses, it's just me giving you time, just so you're aware. Really? You don't think of a confusion matrix as a visual representation? Huh. Check it out since most of you said A, right? I mean, I don't know. It's it's pretty visual as far as I'm concerned, but you know, right? Um, so confusion matrix for visualizing the performance of a multi-class model. This does actually look a lot more like a heat map, honestly, right? So correlation obviously is incorrect because it's just going to how close the predicted is from true. Also shows correlation. These are going to scatter box and box plot are going to show visualizations for predicted and true values, but not really give any insights on the model's performance. I don't know about that, but whatever. In this particular case, right, they are actually looking for a way to say how many times did we predict romance versus it was actually romance. Like they are looking for, like in this case, they want to evaluate how the model is doing against all of the classifications in question. Now, I think that would result in a much bigger box because I don't think we just watch romances, thrillers, and adventures. What about rom-communism? Just saying, right? That's just not romance. It's romance and comedy. Yeah. Questions there? Remember, this is also in a sense to train you to think about how Amazon thinks about these things. By the way, there is a nice little cheat sheet here about the services. So if you are not well versed in the services and you're looking for a kind of en masse way to kind of grab some quick understanding and information, it's right there. Remember, I think I told you before, oh, you know what? Actually, all of these are on the exam except for personalize. Text track is barely there, and deep lens. That's a pretty good cheat sheet, actually. Yeah, I would definitely use that. He's modified that since I last saw it. Cool. All right, going back to our exams. We only got 12 minutes. Okay, we have 2,000 unlabeled images to train an object detection model. We got a team of 5 human labelers. Due to budget constraints, the specialist chooses to leverage a trained labeling model from a previous job to annotate the images. What is the best course of action to label the images, considering that I have a trained labeling model and I've got 5 people? What do I do next? Remember, I got to do cheapest, right? But I still have to get the job done. Okay. So I noticed that a bunch of you put B, which was label the data set using the trained model, put those with low confidence score in S3, and then have Amazon ground truth label them from that point forward. Let's see. Yeah. So that would work, right? Because your model gets trained. If you got a low confidence score, then you just dump it into the S3 bucket. And then in turn, you can present that bucket of the low confidence values back to ground truth. That way you can still get the job done, but you filtered out the ones that you have high certainty about, basically, and you've given the ones with low certainty from your previously trained model to a bunch of human labelers who can then achieve that 95% that we're looking for as far as labeling, right? And since it doesn't like purely rely on people, right? It uses basically active learning to kind of give feedback to a system, right? Then it's really efficient. Okay, two more. Machine learning specialist was given a training data set to create a classification model. The specialist plans to partition this data set into subsets of data will be used to train 5 different versions of the model. The best model shall be decided by its evaluation score. What is the most effective approach for accomplishing this task? What are they talking about here? What do they want? What are they actually wanting to do? Just out of curiosity, what's the challenge with B and C? True. Don't know what kind of data. All right. So I saw a bunch of B's. Is that right? On the same time frame, and then 2 A's. Let's take a look at B. So again, I think it's an interesting extrapolation. I'm going to partition this data set into subsets of data. That's, again, agreed, a little confusing, right? And then to train 5 different versions of the model. Okay, that kind of makes sense, right? So let's look at then about why the other answers are wrong, right? Because these are used for regression type problems and not classification problems, right? And it very clearly says it's a classification problem, right? Fair enough. So, and then it says split the data set into 5 and then model performance through a confusion matrix. That's just going to provide a visualization of the model formed. It's not going to provide a score that's going to be useful for comparison, right? So questions there? Okay. Last one. Data engineering is designing a solution for customer data analysts using Athena. An on-premise application produces the data CSV files in near real time. The engineer needs to convert the data to Parquet before saving it on the S3 bucket. What can you use to capture an on-premise application that produces the CSV in near real time to convert that near real time reception of data into Apache Parquet before it's saved in? And by the way, the method we're looking for is the one with the least configuration overhead, right? So to say this, just to throw this out there, instantly, if you're looking at EC2 instances and EMR, assuming that these could actually do what it's being asked of it, then instantly those are going to be better, right? Because managing EC2 instances and EMR clusters is going to have a lot of configuration overhead relative to the other services. These are more infrastructure and PaaS as a service versus software as a service, which is predominantly what Kinesis represents. So assuming that Kinesis could do that, those would be better options. Now I see that most of you answered B. Let's take a look. Right? Now, why is that a problem? Now, this is just going to where you got to know something a little bit about Kinesis data streams and Firehose delivery, right? In order for that to understand this. So here you've got Kinesis data streams to consume the customer data. So it's going to take it in, right? And then you're going to create a streaming ETL job in Glue to receive the data, convert it into Parquet, and then dump it into S3. But how come this one doesn't work, right? And the main reason is that in this particular case, since we're producing a CSV file, right, we could use Kinesis data streams to ingest the customer data and then configure a Firehose delivery stream to convert the data into Parquet. The problem is that Kinesis data Firehose does not support, right, converting CSV files into Parquet, right? It'll convert JSON into Parquet, but not CSV files. Okay, so I just have to say this really quick. Where's my pause button? Okay, so this is where that cheat sheet, you know, when we were talking about like in the exam guide where it said Kinesis data fire, you probably just want to learn a little bit about it. I got to tell you, this is one of those things where the practice exams come in handy, because are you really going to peel back all the technical details on Kinesis data streams, Kinesis data analytics, Kinesis data Firehose? Not necessarily, but John does have some good cheat sheets that you probably want to look at as far as like just to get some high level blocks. But I would not go through the AWS documentation for this. It's just going to be too much. Okay. All right. So it's 4:58. Technically, we're done for the day. So let me actually stop this for a second. A reminder that tomorrow